والصلاة والسلام على رسول الله محمد بن عبد الله وعلى آله وصحبه ومن والاه وبعد. Good morning, good afternoon, and good evening to irrespective of where you are watching, the vicinity you are watching. If you are at afternoon, I'm saying good afternoon. If it is morning, I'm saying good morning. And if it is evening, I'm saying good evening. Now in our today class, our SWOPS academic online class, I'll be treating some bonus question. Some bonus question that you don't have to skip it. It can actually contribute more to what you want to score at jamb. So I pray Allah should make it easy. Some bonus question that I'll be taking, it is on topic regarding oxidation. Oxidation. Are we? Oxidation. Oxidation. Now, what are the likely questions jamb can ask you regarding this oxidation? Now, oxidation, you can define oxidation in different terms. In so many terms, like more than 6 to 7 definitions for oxidation, but we like to use 2, because the oxidation I'm talking about is not from the redox reaction. I'm talking about merely oxidation reaction. Oxidation. Whereas when I'm saying oxidation reaction, I mean what? Not in terms of oxidation and reduction. In terms of the combining power, that is the definition of oxidation. This can be defined as the art of finding one of the elements in a particular compound or in a radical. When I say compound, I mean this Na2CO3 is a compound, right? The art of finding one amidst them. If this is 1, 2, 3 now, they can ask you to find the oxidation state of sodium. They can ask you to find oxidation state of carbon. They can ask you to find oxidation state of what? Oxygen. The art of finding the oxidation states of each element here in a particular compound, this is a compound, is what we call oxidation. That is the first definition. In order to, jamb will ask you, find the oxidation state of each element here. That is question number 1. Another question under this topic, these are bonus questions that if you attempt it, you feel so happy. That is why we're actually treating it. Don't skip it when you see this. And they are repeated questions. They do repeat them most. Now, when we say in terms of, you are defining oxidation in terms of radical, it has of also finding a particular element. When I say element, I am referring to maybe I have SO4 2 minus. SO4 2 minus. And I'm asked to find the oxidation state of sulfur or the oxidation state of oxygen. The art of finding the oxidation state of this or this. We can in radical. This is in radical. How do I call this radical? This is the compound. How do I call this compound? Whenever you see something like this being put on the board, or you see something CO3 2 minus, something of this, you see them on the board like this, we call them, or you see NH4 plus, you see all this is different from this, right? They are with charges. We call them radical. When I say radical, when I say radical, I mean the coming together of 2 or more elements. This is one element, another element. The coming together of them to form a single unit. We call this one SO4 2 minus, oxide of sulfur. It has been oxide of sulfur. It has been one single entity. Now the same thing. This is ammonium. The coming together of what? Nitrogen and hydrogen. That's what form ammonium. Now with a charge, irrespective of negative or positive charge, is what we call radical. Now you can see physical seeing of this is different from this one. So why are we saying this is a compound now? Why this is a radical? As a result of what makes us to differentiate a compound from radical, this is not having any charge on it. This is the oxidation charge of all this one is minus 2. The oxidation state of all this one is also 2 minus. The oxidation state of this one, ammonium, is also what? +1. So we can actually apply this topic JAMB can ask you find the oxidation state of carbon here. They can ask you to find oxidation state of nitrogen, hydrogen, sulfur, oxygen in radical or in a compound like this. CaOH this. Also in a compound like this. This is slake lime. That is the industrial name for this. The normal name is calcium hydroxide. So they can ask you to find the oxidation state of any one here. So the art of finding the oxidation states of either a compound or a radical like this is what we call oxidation reaction. I'm defining it in terms of this particular topic. When we want to define it in terms of oxidation and reduction, that is when you'll be adding addition of oxygen, removal of hydrogen. So that's not what we are actually going to. So that is the first question that JAMB might ask you. Find the oxidation state of any of these something. Is either in a compound or in a radical. That's one. The second thing, I've explained what a compound is. There will not be any charge here. Here is also a compound but with charge. When you have a element with another element coming together to form a single entity, oxide of sulfur, thiazocarbonate of what? Which is oxide of carbon. This is also ammonium. So when you have this, we call them, and they are having a charge that you can see. We call it what? We call it a radical. So we can find the oxidation state of the compound when we can also find the oxidation state of each element in a radical. Hope I'm communicating. That is the first question that JAMB might actually ask you. The second question that JAMB might actually ask you that what is the name of this? What is the IUPAC name? That means the full meaning of this is International Union of Pure Applied Chemistry. What do they call this one? What do they call this? We call this sodium thiazocarbonate 4. How do we say this one should be 4? Where do they get that? What would be the IUPAC name of H2SO4? What would be the IUPAC name? So these are the two questions that it's mostly common to ask. And if you know it from this source academic online class, it's a bonus question. And it's also a repeated question. That is why we're actually treating it. This is tetraoxosulfate 6 acid. It's not that maybe they add this 2 plus 4 in order to get 6. How do they get 6? It's as a result of this IUPAC. Firstly, I said the two main paramount two questions that they do repeat on as far as this topic is concerned is that they can ask you to find the oxidation state of each element, either in a compound like this, or in a radical. It has a rule. I need you to follow me based on the rule. The rules are very simple. It's just two rules guiding oxidation. How do we do that in terms of finding the oxidation state? Then in terms of finding the IUPAC, it also has two rules. The two rules apply for finding the oxidation state of each one and finding the name, IUPAC name of each one. These are the two questions that they do repeat. Check any year from the series. You'll be seeing a question related to this. They are common and they are very simple. Simple question. Whereas you don't have to skip it. You have to understand it. Why too they do have all these things for those preparing for why. This video is not a waste of time for the JAMB and for the what? For the WAEC student. Are we together? Now, let me state the rules. Are we? I've explained now that is either you find the IUPAC name or you find the what? Oxidation state. Are we together? Now, the rules now applies that. Let's see the rules guiding this particular topic. I will just advise you that there are two rules guiding this. Based on the summary and the comprehend the research being made here is as a result of know that when you are dealing with a compound like Na2CO3, when you are dealing with a compound like this and you have to find either the IUPAC or the oxidation state of each element here, you have to equate this to be 0. That is rule 1. If it is compound, this is compound. No, rule 1 states that if it is compound like this one, the coming together of 1, 2, 3 elements to form a compound, and there is no charge on top like +2, -1, feasible one, you equate it to be 0, and you make use of their what? You make use of their charges. I mean their outer valency in order to solve any of this question. And in terms of IUPAC. But if it is radical, as I explained earlier, SO4 2-, that is where we do make a mistake. You won't equate it to be 0. These are the two rules. Please try and note that. This is a compound, you equate it to be 0. Why this radical? What is he having? The oxidation state of all this now. If jamb asks you, what is the oxidation state of all this? Assuming if it is reduction and oxidation that we are doing, which we are not really doing today. But if it is oxidation state of all this they want, it is -2. But if it is each one now, since this is radical, the whole this thing is radical, as a result of, I told you that the coming together of two or more elements to form a single unit with a charge, plus or minus, is what we call radical. That is the definition of that. And I've defined oxidation state. Now you will equate this to be -2. The charge that is carrying, that is what you are going to put here. If it is NH4 plus, what is the charge that is carrying? +1. That is what you are going to put here, +1. If it is CO3 2 minus, is a radical. The charge that is carrying is what? -2. You put -2 here, not 0. But if it is a compound, H2SO4, you put what? 0. If it is HNO3, is also a compound, you put 0. These are the two rules guiding that. Now let's try and be visiting question. Before we visit question, what are the last thing that I will say before we treating question is that how do we, assuming we have this, let's firstly pick that of compound. We have this. How do we solve this? You know that the first thing is equated to 0. Now they ask us to find the oxidation states of carbon. Well, firstly I'm using this one now. Forget about this IUPAC. Let's firstly solve this question. You have to find the oxidation state of carbon here. All you need to do is that you make carbon unknown and you find the outer valency of this one and you find the outer valency of this one. Know that sodium is what? Atomic number what? 11, isn't it? We are going to make use of the atomic number. Hydrogen, helium, lithium, beryllium, boron. Sodium fall on atomic number what? 11. So then you will now do, since sodium fall on atomic number 11. Are we together? The next thing to do, you do the EC. When I say EC, I mean 11.